God. Here we go. More absolute value. So, we're going to do a little bit more with graphing and tables, functions, and practicing domain and range, because domain and range can be quite tricky. Students can have trouble with that. So, let's get into it. Absolute value function. So, of course, the function will be written in the form of f of x. That's what I always associate with the word function, f of x. Okay, you should always connect those two in your mind. And the absolute value of x is the basic function with no other stuff with it. Okay, just that. So what this looks like on the graph is, well, let's just put it in Desmos to see. Now, usually, if I'm correct, let me see, I might not be correct. I'm going to type this in like the way it is. Okay, yeah, that works. Alright, so you can type it in like that. You can also, of course, replace this with y, which is much simpler to type in. And that gives you the same thing. And notice what happens in Desmos is if you have the same function. So if we eliminate this one, so clicking on this color will take away the red, and you see the black. They're the same equation, same graph. They will overlap each other, so it'll be hard. You won't be able to see the first one. You'll only be able to see the second one. So keep that in mind. That'll happen sometimes. If you happen to have two equations that are the exact same, one will cover up the other one, but you can see the other one if you eliminate the other one. Yeah. Did I say the other one again? Anyway, so looking at this graph, this is what we got. Now we're going to sketch it on there, but they also want us to do the table. And one thing you can do is you can click here, your settings, and you can say, click this, convert to table. So then it'll actually bring up a table with some points in it. I believe you can add in more points. Yes, so you can add in more numbers, any other number you want, -100. Yeah, any number you want, and that's how you can get the table. So pretty nice, pretty nice. A little bit easier, but you got then I think the handheld calculator. There's a lot more places to go and things to do, but Desmos is just super friendly with this. So, yeah. Now back to this. So that table, we can take some of those values. Usually, what they like is the vertex to be in the middle of the table. So I'll just go ahead and fill these in. This was 3, 2, 1, 0. So the original vertex of any function is 0, 0. And then since it's absolute value, we have no negative values for our y's. And then we can, of course, graph this 0, 0, 1, 1, 2, 2, 3, 3, -1, 1, -2, 2, -3, 3, and etc. Woo! I went a little bit off. Sorry about that. I wonder if I can erase that. Oh, yes. Success! Okay. Now, domain and range. So, domain is my x's. Range is the y's. So, this is coming from, and other thing is left to right. And then what's happening up to down. Okay. Let's start left to right on my x's and say, alright, where is my function? Is my function anywhere here? Yeah, it keeps on going forever and ever and ever. So yes, so my function exists. And then I keep going and I ask myself, okay, is there any place where it doesn't exist? No, it keeps going. Yeah, so it's continuous from left to right. So this is all real numbers. Remember that? The fancy R. Well, no, don't worry about the brackets. Okay, we'll put brackets. I can't decide. Alright. Now the range, up and down. So I put up first, but really I start with the negatives first. So start with your negatives, okay, which is down here. This is where my down is, and then I go up my axis and I ask myself, okay, where is my graph? I have no graph. No graph at all in quadrant 3 or quadrant 4. Nothing until I get to right here. My original absolute value doesn't start till right here. And that is at what number? Negative 1, 2, 3, 4, none of those, but it starts at 0. So my range will start at 0. And, oh yeah, we're going to do this in set notation. So y is it greater? Yeah, definitely. Greater than or equal to 0 is what it is. So then the rest of the graph is only contained in these two, and it goes forever in the upwards direction. Okay. So again, domain and range, people usually, if you're going to struggle, you're going to struggle with domain and range. That can be tricky. So we'll do a handful of these together. And then, of course, you can have brackets. So if this is set notation, we need y such that y is greater than 0. All right. So the absolute value function graphs, they typically look like a V. They are V graphs. Oh. And the turning point, or right here, right there, is called the vertex. I already said that. All right. This has a lot of details on graphing, just generic graphing, but of course the graphing calculator in Desmos does a lot of this for us. They like to put the vertex in the middle of the graph, but I'm not going to count off if you don't do that. I mean, that's not a big deal, but it does help with if someone was graphing it by hand, if they had the table in the table, if they only had the table and the table had the vertex in it, that would be useful. So, I'm not going to go too crazy over these. Let's just go ahead and look at, I'm just going to emphasize this. Let's put Desmos. Of course, we can do these in Desmos. So we're going to start with this one. Let's put y equals absolute value of x minus 4. Or I can just type in 4. All right, now that was my old one. Okay, so just like this, there is only the graph. Now that's fine. We can take a look at these points and fill them in. Do we have any? Oh, they didn't give us any numbers. So let's just pick, well, we can just do the table and then see what we get. So up here, again, click the settings and then convert to table. Oh, last time it took away the table. That's kind of nice. So -2 and 6. -1 and 5. You can probably see a pattern here. 0, 4. Yep. I'll just go ahead and fill these in. Is it 3, 2? Yeah. 3, 2. Is 3 at 3, 1. Yep. And 4 is at 4, 0. Alright, so, well, there's my vertex. You could have this shifted a little bit and have 1, 2, 3, 4 shifted up, and then you have a few more points, but we got the general idea. So if you're just going to redo a graph, slope is 1, so I don't have to, I know I'm not going to have anything crazy. The slope will be the same on both sides, okay? Or at least this is the negative version and this is the positive version of that slope. Alright, there's your graph. Alright, let's do domain and range. So domain is my left to right on my x's. So what will my x's be? Let's see, starting out here, I don't see anything but this is an arrow, so imagine this keeps going, and yes, my graph does exist to the left, and as I keep going, it also exists way out to the right, so it is all real numbers. Let's just drop the brackets. It's fine. Alright, the range is up or down to up. So start down. Does my graph exist down here? Nope. Doesn't exist until I get to 0. So we have the same thing as before. Y all my y's are greater than or equal to 0. In other words, all of the points that contain y values are going to be 0 or greater. All of these points are up. Okay? That's the only way to get all of these points on this line is to go up from the origin. And it's a solid dot because you can include 0. 0 minus 4 is negative 4. Absolute value of negative 4 is 0. So you can, as long as there's a filled in circle, you're good to have it equals. So yeah, so that's not too bad, right? Alright, let's do another one. Just to see, well, what happens. Let's do one that comes out a little bit different. Alright, number 2, you shouldn't have trouble with that one. That one's pretty good. Alright, let's look at the next page. Number 3. Okay, yeah, let's do 3. Alright, absolute value of x plus 5. So we have something outside of the absolute value. Yes, I'm going to just go straight to it. Why not? Where is my graph? So zoom out, find your graph. Oh, so that's what happens. Here we go, and then the table's right there already for me. Man, we are some spoiled people. We got this awesome calculator doing all of this work for us. Negative 2 and 7. Negative 1 and 6. 0, 5. 1, 6. 2, 7. There's some points to go off of. And where was our vertex? At 0, 5. 0, 1, 2, 3, 4, 5. And then negative 1, 6. Negative 2, 7. So you see some patterns in the graphs of these. There we go. Alright, now let's do domain and range. Okay, if we start from left to right, do we have any restrictions? Is our graph stopped anywhere? No, it's got an arrow going out this way and that way, so it's going to be the same, all real numbers. It can include any x and any negative x and any positive x is included in this graph, but what about the range? Nothing, 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 nothing. So starting from low, I have nothing until I get to 5. So that means all my y's, and then we'll go up. All my y's are greater than or equal to 5. There you are. All right. Let's see. Number 4, you should be okay. Number 5, you should be okay. Let's just look at 6. Just to see something slightly different, a fraction in there. So let's see what that looks like. 1/2 x plus 1. (1/2 x plus 1 minus 4). Oh. Look how stretched out that graph is. As it was a steeper V, more looked like a normal V, and now it's flattened out a little bit. Alright, here are some coordinates that we can use. So just notice that some of these are 0.5s, and you should be good with this. There's nothing too crazy. Let's look at domain and range, and then I'll let you finish these. So domain, starting left to right, starting from the left. Yep, my graph exists to the left. Well, Desmos would be, excuse me, choking on something. V. It's a little bit easier to see what I mean by it goes on forever to the left. So I'm coming from the left, and I have my graph, and then as I keep going, I look for a place where it stops, and it never stops. So that is all real numbers for that one. And then my range, my down to up. So I start down, nothing, 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 until I get to this number, which is what? Negative 4? Yep. So my graph exists on my y values from negative 4, and then they all continue up. They're out here, but they still all continue to increase as they go this way. So therefore, your range would be y greater than or equal to -4. Okay? Alright, so you're going to practice some of these, and you are not going to worry about 7 and 8 right now. Just put a small x over them, and just in case we come back to them, we may not, depends if I remember or not. So, and then we'll come back to that. So why don't you guys try the rest of these problems that we didn't do, number 2s through 6, finish those out, press pause, and then when you're ready to see the answers, press play. Okay, here we go. Here's number 2. Again, I'm not worried about the exact numbers in the table, as I have, as long as you've got some enough to show that it's the right graph. So here's the graph. Domain is all real numbers. Range is greater than or equal to 0. Number 4 looks like this. And domain is all real numbers. Range is greater than or equal to 0. Number 5, a little bit different. This is the graph. And domain is all real numbers. Range is less than or equal to 0. Alright, so we're going to jump down to the next page for this section. Okay. So this is going to be the same idea except inequalities. And inequalities is also always going to change our graph. Less, greater than, less than. So we have the value, we'll graph, and then this is the main difference. There will be some shading. Okay, shading will depend on the symbol. So let's get started. Go ahead and pull up Desmos, and let's go ahead and graph the first one. Just see what it looks like. F of x is less than, so I'm going to change this to less than, and then I push equal symbol on my keyboard, and the equal bar will show up. X plus 1, absolute value of x plus 1. Let's delete all this other stuff. Okay. Alright, what do they want here? Oh, it's not equal. Silly. Okay, well, it's still not showing up. So, let's see if changing this to y makes a difference. Yes, it does. Alright, so it looks like we got to stick with y when we do the inequalities here in Desmos. Alright, and there's my v graph. However, it is shaded. Okay. So my vertex, the most important place to start out, is at -1, 0. -1, 0. Other points that it had was 0, 1, 1, 2, and etc. -2, 1, -3, 2, and then go ahead and plot this. And again, our slopes are the same, just going in opposite directions, opposite sign directions. And, oh, I forgot. Now, let's see if I can undo that. There's my points. Okay, now, big thing to remember is if there's no equal bar, we have to make these lines dashed. Not solid. So if it's solid, it has the equal bar. If it's dashed, it does not have the equal bar. And then since this is less than, and you can figure this out without even graphing it in Desmos, all the less than values will go down from the V. So that's where you shade. Down. Alright. Not too bad, huh? Easy peasy lemon squeezy. Okay, well, there's not much to do on this page, just some practice problems. Do we have, no, we don't have to worry about domain and range on these. So we're just checking out the graphs and filling in the table. So go ahead and practice some of these, see what they look like, and we should be good with that. And so go ahead and press pause, and then press play when you're ready to see them. Okay, here's what number 2 should look like. Here is number 3. Notice if I do want the vertex, or if you wanted to know the vertex, you can click there where the vertex is and it'll give you the exact coordinate. Okay. Here is what number 4 looks like. This is number 5. And here is question 6. Alright, that is the end of this lesson. So, one more lesson to go for this unit on absolute values.